purpose of this practice is to make the 5 tests that we did before with the material 1018, that is a steel, and to prove that we actually learn how to make all the tests. For the tensile test, first we measure the initial length and also the initial diameter. With those values we got the initial area. We put the type of material in the software and also the diameter in millimeters, and after some calculations we got a value for the yield strength of 59,701.49 psi and a tensile strength of 81.044.77 psi and an elasticity modulus of 22.4 times 10 power to the 6 psi. The maximum strain that we got was 0.24 and the percentage of elongations was a total of 24% and the percentage of error reduction was of 64%. Then I compare these values with the ones that are in tables and calculate the percentage of error. For the yield strength I got an 11.17%, for the tensile strength at 27.2%. In the elasticity modulus, I got a 24.57%. For the Brunel harness test, we applied a load of 2,000 kilograms and we got an average diameter of 2.67 with the 3 indentations and an average of the harness of 352, that is a practical one. And then we use this average for the theoretical one and got a result of 350.72, while the investigated one was of 126. As we can see, the practical and theoretical values are really similar. But when we compare it with the investigated one, we can see that it's doubling its value. Then we did the Rockwell harness test and we did it 3 times. We got an average of harness C of 23.67 and an harness B of 53.67. The investigated one for C was 0, for B was 71. As we can see, the harness that we got practical was less than the one that is on tables. For the Vickers harness test, first we needed to make the backlight. After that we used the automatic Vickers and got the values of 190, 185 and 190. So the average of those is the practical result, that is 188.33. And then we use the diagonals of those values and use the formula in order to get the theoretical value, that is 188.40. So the theoretical and practical are really similar, and the investigated one was of 131, and as we can see, there is like a considerable difference between the values. For the impact test, we did it at a room temperature and it was Sharpie type, and the energy absorbed by the material was of 40 foot-pounds. Then we analyzed the type of fracture that we got by doing this test, and as we can see, it was ductile. After doing the Vickers test, we could give the backlight a chemical attack, and with this we could see the grains at a magnitude of 100, of 500 and of 1000. Then we calculated the number of grains in the micrograph of 5000. We counted a total of 16 grains, and with this value we applied a formula and we got a total of 9 ASTM. During this final practice, I realized that the practice makes the master. Even when you think that you know how to do the tests, until you practice and do them with less help, you will master them. This practice helped me to actually apply the knowledge that I got during the semester, and I made some mistakes during this practice, but I think that you learn way more from the mistakes. Since the materials are really important for my career, it's really important for me to know how to make the tests. So I believe that this practice is one of the most important because it proves that you actually learned in the semester.